Opening up the right hand side, the given equation can be written as z raised to the power 4 is equal to 5 times in brackets z cube minus z square plus z minus z square plus z minus 1. Moving all terms to the left hand side, this equation can be written as z raised to the power 4 minus 5 times z cube plus 10 times z square minus 10 times z plus 5 is equal to 0. Now multiply this equation with z. We get z raised to the power 5 minus 5 times z raised to the power 4 plus 10 times z cube minus 10 times z square plus 5 times z is equal to 0. Let's call this equation 1. Now note that z is equal to 0 is a solution of equation 1 introduced because of the multiplication by z earlier. However, z is equal to 0 is clearly not a solution of the original equation. Keeping this in mind, we go back to equation 1, which is z raised to the power 5 minus 5 times z raised to the power 4 plus 10 times z cube minus 10 times z square plus 5z is equal to 0. Subtract 1 from both sides. Now note that the left hand side is the binomial expansion of z minus 1 raised to the power 5. Therefore, z minus 1 raised to the power 5 is equal to minus 1. Now the right hand side, minus 1, can be expressed as cos pi plus I times sin pi, which can be written as cos of 2r pi plus I times sine of 2r pi plus pi, where r is an integer. Using De Moivre's theorem, it follows that z minus 1 is equal to cos of 2r plus 1 times pi upon 5 plus I times sine of 2r plus 1 times pi upon 5, where r takes on the values 0, 1, 2, 3 and 4. Therefore, z is equal to 1 plus cos of 2r plus 1 times pi upon 5 plus I times sine of 2r plus 1 times pi upon 5, where r is equal to 0, 1, 2, 3 or 4. Now note that when r is equal to 2, the value of z is equal to 1 plus cos of 4 plus 1 times pi upon 5 plus I times sine of 4 plus 1 times pi upon 5. And this is equal to 1 plus cos pi plus I times sine pi. Now sine pi is equal to 0 and cos pi is equal to minus 1. Therefore, z is equal to 1 minus 1, which is equal to 0. But we have noted earlier that z is equal to 0 is not a solution of the original equation. Therefore, r is equal to 2 is ruled out. Therefore, the solution of the given equation is equal to 1 plus cos of 2r plus 1 times pi upon 5 plus I times sine of 2r plus 1 times pi upon 5, where r takes on the values 0, 1, 3 and 4. And this is the required answer.